Okay, let's talk about these proofs. Now, all the stuff leading up to these proofs is good stuff, but I'll be honest, the proofs are really the proof in the pudding, so to speak, not to pick a pun. So if you can do these proofs and you understand how to do these proofs, then you should be golden on the test, and that's just the bottom line. All right, so we have these triangles I want to prove congruent. All right, so we're not told a lot, but the picture is worth 1,000 words. So the first thing we have to do is decide how in the world we are going to prove this. So I'm not going to go through the super formal version of this, but I want to talk through just kind of how we're going to figure this out. And the first thing we have to do is, since we're not given any givens in this particular case, is to mark the diagram with stuff that I know is going to be true. And remember, since I'm trying to prove triangles are congruent, um, in this particular case, MAH and then THA, which is going to be the upper and lower triangles, I really have to decide which of these triangle congruency shortcuts are going to be viable for me. So I'm just going to jump into it. All right. So I first thing that pops out at me is I have this line in the middle, and I'm going to make a note here that this is provable by the reflexive property, which simply states that anything is congruent to itself, right? So AH is congruent to AH, but what importantly this gives me is a side length. So I'm already uh, recognizing that I have a side length. Right? Uh, that kind of leaves me in an impasse because I don't really have anything else. So I probably can't prove anything more about sides, period. Which tells me that my only two that I'll probably be able to use is going to be angle, angle, side, and angle, side, angle, which means I need a lot of information about angles because sides, they're not going anywhere. I know they're all parallel because it's a parallelogram, but I don't know anything more. So I have to dig deep here. I have to think about stuff that I've seen and how can I apply it in new ways. So the place my mind goes is that I do have parallel lines. I'm going to go ahead and augment my diagram here. I have these two parallel lines, and I even have some transversals. Namely, I have this transversal right here. So my curiosity is, how in the world can I use that to find information about angles? Well, if I take advantage of digital ink here, I'm going to drag these guys away, or this diagram, I'm going to put it down here just temporarily. So if I'm focusing on this idea of two parallel lines cut by a transversal, I know right away that I do have certain angles that are congruent. For example, I have these two angles right here, which are ultra interior angles. And if these lines are parallel, those angles end up being congruent. So if I know that is true, let me bring this guy back to my drawing and put it right back in place. Well, check out that. Alternate interior angles have to be congruent, and when I lay it on top of my diagram, I have two alternate interior angles which are precisely congruent, which tells me which tells me I do have other information I can grab. So I'm going to mark those here in a second, but I want to demonstrate a common misunderstanding that I don't want you guys to fall into because this does give me two more angles, which is great news. But here is what I've seen people do in the past. I don't want you to make the same mistake. So they recognize that those two angles are congruent. And they're like, hey, look, I have these angles right here, which also should be congruent because those are alternate exterior, right? Which is true, but look what happens when I resuperimpose the picture onto my diagram. Right? So pay close. Oh, excuse me. Let me move that back. Okay. So I want you to pay close attention to this right here. If you look at the black line, that represents the diagram I have. But look at the purple angle. It actually stretches before the black line through it into this. Another way to say that is I don't even have angles that are marked currently in purple. I just don't have them. Well, people say, well, look, well, how about these angles? Oh, too much, Mr. Collins. How are these angles right here? This guy right here. Well, that's all well and good, except, again, when I pull my picture away, when I pull this picture away for examination, good lord, let's try one more time. Okay. When I pull this picture away for examination, notice that that is not even a full angle. It starts right here and then goes to the line. But my angle should be from line to line. So please don't fall into those two really, really common traps. Please make sure if you pick an angle based on a drawing like this, that is actually a full angle, just not part of one. Um, so so just to make sure we're kind of on this, oh, get out of here. We're on the same page as my notability goes absolutely bananas. To make sure we're on the same page, just get that back aligned. That's pretty good right there. I do have another set of angles because of alternate interior, and that's an important thing to note because now I'm a little bit closer to my cause. I do have angle 1 because of alternate interior. Okay, so I have those angles as well. So I took advantage of the top and bottom parallel lines. So guess what it's time to do now? Let's take advantage of these other parallel lines that run MA and TH. So again, I'm going to do my superimposed drawing. I'm going to note that I have a transversal. You might be seeing it right now, which angles happen to be congruent. If not, let's go ahead and pull this away for dramatic. Ooh, get out of here, triangle. Let's pull this away for dramatic effect. Oh, you don't want to play either little line over here? Fine, I'll pull you separately. Okay. So again, you might see these angles right away, but if not, pull it away. I do have another set of angles here because I do have parallel lines cut by this transversal. Okay. I do have these lines cut by this transversal, so it should be true that these angles end up being congruent as well. Well, the good news is that gives me a third set of angles to actually prove this. Okay. So it looks like I do have angle side angle. I have this red one because of alternate interior. I have the reflexive in the middle that's shared. Then I have the pink on the ends that are going to be also alternate interior angles by the theorem, just in kind of a different direction. So with that being said, let's go ahead and write our proof. So angle 1, and you know what I'm going to do? I'm going to come back with my diagram. I'm going to actually, instead of having to name these angles by like MAH, THA by those three letters, I'm just going to go ahead and renumber these 1, 2, 3, and 4, which is a totally legal thing to do. So it'll make my proof writing process easier. So let's see. Our first angle, I'm going to name angle 2 being congruent to angle 4. And the reason I'm going to give that is because of the alternate interior angles theorem. And don't forget the word theorem because that is a thing that tells you because you have parallel lines, you have congruent angles. In the middle, I have a side, and that's going to be AH, and it's congruent to itself, AH, because of the reflexive property. And then angle 2, or I'm sorry, the second angle, I should say, will be angle 1, and that's congruent to angle 3, again, because of the alternate interior angles theorem. Okay? And because although we have three pieces that turn out to be very true, if I combine them into a single statement, that will actually give me triangle MAH is congruent to triangle THA because of angle side angle triangle congruence theorem. And I am done. Okay. So again, just a quick review because I ended up talking about some kind of common misconceptions in there. I do have enough to prove these triangles are congruent. I have the reflexive line in the middle, and then either using the side parallel lines to generate like angle 1 and angle 3 being congruent, and the top and bottom to generate angle 2 and angle 4 being congruent. I have enough for side angle side congruency, which is ultimately what I proved, and now I have my triangles also proved congruent. All right, so that's that one.